Hello students, now we will discuss electrical instruments. Ammeter. Ammeter. Ammeter is an instrument used to measure the electric current in the electrical circuit. A galvanometer can be converted into ammeter by connecting a very low resistance called shunt resistance parallel to it, that is parallel to galvanometer. Suppose a galvanometer of resistance capital G, let this is a galvanometer of resistance capital G. It gives full scale deflection when current Ig is passed through it. That is, Ig is the maximum current which can pass through galvanometer. Let a very small resistance capital S, this is S resistance, it is very small resistance, is connected parallel to the galvanometer. This is connected parallel to the galvanometer to convert it into ammeter of range 0 to capital I. This means now capital I current can pass through this combination which is very much greater than Ig. Therefore, when current capital I is passed through the combination, the current through the galvanometer is Ig. That is, current passing through the galvanometer remain same Ig, and remaining current will pass through the shunt resistance S. The remaining current I minus Ig pass through shunt resistance S. Since shunt resistance S and galvanometer capital G are connected parallel to each other, therefore potential difference across S, the shunt resistance, is equal to potential difference across the galvanometer G. Therefore, according to Ohm's law, potential difference across S is I minus Ig into S, as V is equal to I into R. Therefore, I minus Ig into S is equal to Ig into capital G. This implies S is equal to Ig into capital G upon I minus Ig, or S is equal to Ig upon I minus Ig into G, the resistance of galvanometer. Let it be equation number 1. Now if Ig is very much less than capital I, then I minus Ig is nearly equal to I. Therefore, in this case, S is equal to Ig upon capital I into G, the resistance of galvanometer. Let it be question number 2. Therefore, by knowing the value of Ig and capital G, we can find the value of shunt resistance capital S, which is connected parallel to the galvanometer, to make it ammeter of range 0 to capital I, and I is very much greater than Ig. The resistance of the ammeter is given by as S is connected parallel to galvanometer. Therefore, 1 upon Ra, the resistance of ammeter, is equal to 1 upon S plus 1 upon G. This implies 1 upon Ra is equal to LCM is S into G in the right hand side, and numerator becomes G plus S, and this implies 1 upon Ra is equal to S plus G upon Sg, that is by rearranging, or Ra, the resistance of ammeter, is equal to S into G upon S plus G, where S is shunt resistance, very low resistance, and capital G is resistance of galvanometer. Put it question number 3. The resistance of ammeter is less than capital G, the resistance of galvanometer, because in parallel combination, equivalent resistance is always less than each resistance connected in parallel. Now properties, mean properties of ammeter. First one, ammeter is always connected in series. Number 2, resistance of ammeter is very small. By connecting ammeter in the circuit, it does not change the current passing through the circuit. Third one, resistance of ideal ammeter is 0. Resistance of ideal ammeter is 0. This parallel combination of galvanometer and shunt resistance, that is S is connected parallel to G, and this combination is called ammeter A of maximum current which can measure is equal to I. That is, this parallel combination of galvanometer and shunt resistance is called ammeter of range 0 to capital I. That is, now current capital I, which is very much greater than Ig, can pass through it, or we can measure the current capital I, which is very much greater than Ig. This is something about the ammeter. So thank you very much.